All right, this is 6th grade Excel, lesson number 2. We're going to be looking at a bunch of different kinds of graphs today and learning how to interpret graphs, to understand them, to do word problems having to do with these graphs. So this should be mostly review for you, but listen carefully so that you understand how I expect you to work on these types of problems. It says, first of all, circle or pie graphs are used primarily, that means mostly, to organize data. That means to show you numbers, information that's in number form. Picture graphs use symbols and pictures to compare data, to compare number information. Bar graphs use multiple bars to compare data. Line graphs are used to show change over time. Change over time. That's important for you guys to know. Four different kinds of graphs that we're going to be looking at. Circle or pie graphs, number 1. Picture graphs, number 2, bar graphs, and then line graphs. Make sure by the end of this lesson that you understand the difference between the 4 and why there are 4 different kinds of graphs. Why would we want to even have those kinds of 4 different graphs? All right, the first one, what do you think this one's called out of these 4 here? Well, that's called a bar graph because we have bars going up. And down at the bottom is a key that explains the graph to you. Paul, Gail, and Shawn. These first bars for each one over here are Paul's information. The second bar on each one is Gail's information, and the last bar for each one is Shawn's information. You see that we have Jan, Feb, Mar here. These would be the months of the year, of course. And over on the side it says days. This is called a label, and that means that the numbers going up the side of the graph are how many days, and that would probably be how many days in January. Let's take a look at the title of the graph. It says part-time employees work days. So in understanding this graph, I think that Paul worked 15 hours in January because his bar goes up to this line which comes over to the 15. Paul worked 15 hours in January. I see that Gail in March worked 5 hours because her bar comes right up to the 5 line. All right, what we're going to do then is solve these word problems over here that are based on this bar graph. And bar graphs are used to compare. It's very good for comparing because we can see that like Shawn worked a lot more than the other people in March there, you know, that kind of a thing. All right, the first problem says, how many more days did Gail work in January than Shawn? Let's do this one together. Gail worked, this is Gail's in the middle, 20 right there, and Shawn, which is this last bar, worked 10. And it says, how much more did Gail work than Shawn? You got to watch out, because sometimes on the Excel they're going to say, how much more did Shawn work than Gail, which the answer would be 0 because he didn't work more than Gail. But in this case, it's not a trick problem. Gail did work more than Shawn, and Gail worked 20, and Shawn worked 10, so the answer would be 10 hours more. You got to put a label with this, and we know that, oh, days. See, I got the label wrong. It's 10 days. Let me erase that and fix that. I was double checking my work, which you should always do. I was looking over here. It says how many more days, 10 days, and the word days is used up here as well. So notice how I showed my work here. I put a label with my answer because it is a word problem. I want you to pause the video, do number 2 on your own, turn it back on when you're ready to see the solution. How many days did Paul and Shawn work in May? Here's May, Paul and Shawn. Paul worked 15. Right? Shawn worked 5, so you should write 15 plus 5 is 20. 20 days altogether for the 2 of them. All right, here is another kind of graph, and you can see that we have lines going across the graph. So what kind of graph do you think this is? Yes, this would be a line graph. Let's look at the title of the graph up here first. High temperatures during the first week in June. So here are the days. There are 7 days in a week, so each one of these numbers represents the days in June. This would be June 1st, that would be June 7th. And then I look on the side of the graph at the label there, and it says temperature. It says degrees in Celsius. So these are not Fahrenheit temperatures like you and I use here where we live. This is what they would use in pretty much the rest of the world. And the days in June are for 2000, 2001, and 2002 by looking at the key down at the bottom of the graph. So let's take a look and kind of understand this a little bit better. On June the 1st, in the year 2002, that's the red line here, that red line crosses right there that means it was 24 degrees for a high temperature on June the 1st in 2002. Now, what was the temperature in 2001? 2001 on June the 1st, here's the green line, that meets with the 1, where the 1 comes up right there, at 25 degrees. Now, what about the year 2000? Well, that's the little dotted line, and that dotted line's going along here, and that would meet right there on June the 1st, and that would be 26 degrees. And you can see that the 2000 moves down here, then up here, down here, over to here, and so on. The 2001 line moving along like that, and then here's the 2002 line moving through like this. Okay, I'm going to get rid of all this stuff off the screen to make it a little bit easier for you to read. And we're going to solve these two word problems. In fact, I'm going to go ahead and let you try 3 and 4 on your own. Pause the video, turn it back on when you're ready to see the solution. How much cooler was it on the second day of June in 2000 than in 2001? Here's the second day of June right here, and we're looking for 2000 and 2001. So 2000 on the second day. I like to put the little dots on my graph because that helps me to keep it really straight. 2001 is the green one, and so 2001 we can see it was 26 degrees, and 2000 we can see it was 24 degrees. So how much cooler was it? 26 minus 24, and that would be 2 degrees Celsius. My label here, which I'm sure many of you probably messed up on, is that label right there. It's 2 somethings. It's 2 degrees. That little 0 up there, that little circle, means degrees, and the capital C stands for Celsius. We have to put that on there because otherwise it could be 2 degrees Fahrenheit, which is very different than Celsius. All right, number 4 says, how much warmer was it on the 3rd day of June in 2002 than in 2000? The 3rd day of June, 2002, that's way up here, again at 26 degrees. And the year 2000 would be right down here on the 3rd day of June. I am dealing with the 3rd day of June, so it has to be on this line right here. So the dotted line meets up with the 3rd day of June line right here, and the red line meets up there at 26 degrees. So this one's 26, that one's 22. We should write 26 minus 22, so the answer is 4 degrees Celsius. All right, and this next kind of a graph, as it tells you here, is called a histogram. It's a type of graph used when you want to group the data. Our example shows the amount of time it took students to complete a math test. We put the information into a tally chart. You will need to know the least amount of time a student took to the greatest amount of time, because the first part has to start with the least amount, and you have to have a section that's for the greatest amount. This is the range of the data. Next, decide how to divide the range into equal parts. We use 5-minute intervals. They used 5-minute intervals here. So on a histogram, they said, well, the most that anybody did was 25, and the least anybody did was 0. So that makes the range of numbers, the span of numbers, from largest to smallest being 25. That's called the range. All right, the range of the data. Let's say the lowest number was 28 and the highest number was 48. Well, the range of that data range would be 20 from the lowest up to the highest. So once you figure out what the range is, you figure out how you want to group this. And they decided to do it in 5-minute chunks. Notice it goes from 0 to 5 and then 6 to 10. They don't go from 5 to 10 here. If they wrote a 5 here and somebody did 5 minutes, a student did 5 minutes, where would you put the tally mark, here or here? There, you have no way of knowing that because there's a 5 on both spots. So you got to make sure that they don't overlap at all. And then what they did was they put tallies. There's one kid that took 0 to 5 minutes, another 3 kids that did 6 to 10 minutes, 6 kids that did 11 to 15, 5 that did 16 to 20, and 4 that did 21 to 25 minutes. All right, if that was too fast for you, just go back and watch it again on histogram. The next thing that we're going to look at is a different kind of bar graph here. And they take the histogram, which is right here, and they transfer it, tally chart, I'm sorry, this is a tally chart. They transfer that into a histogram. The histogram is a lot like a bar chart, a bar graph, and the number of students are listed on the side. You can see the label there. The time needed to complete the math test. That's what the title of the graph is, and then they put the different ranges or intervals down along the bottom. And so there was one that did 0 to 5. We can see that here. And then 3 of them that did 6 to 10, and so on. Create 3 statements about the information in this graph. How could the information about taking a test help the teacher of this class? Well, we know that very few students took 0 to 5 minutes. Most kids in the class took, or the greatest time interval was from 11 to 15. And we can see that if you really look at this information here, we see that most of the kids in the class are taking between 11 and 25 minutes. And what that can help the teacher with is to know how much time to give the students on their test. They pretty much are going to need close to the 25 minutes, maybe at least 20 minutes to complete the test. That might give these kids a little bit of a push to speed up and to get their test done a little bit more quickly. All right, thanks for watching.